Hey everybody, welcome to my new YouTube channel. I'm stranded here in beautiful sunny Whitehall, Montana. I figured I would start a new YouTube channel because I'm splitting off from my old one. So today's topic is Phthorapathy, and it's kind of a crazy sounding and crazy looking word, but what it means is disease through decay, or rather competition through decay. And so what I mean by that is a plant or other organism competing maliciously with another organism through its own death or decay. So I'm going to give you an example. Right behind me here, you can see that there's all this dead grass. Now, today's date happens to be March 1st, and you might be wondering why grass here in Montana, where the growing season ends in September, why this grass is still standing. And when we look at this grass, we realize that it probably stopped growing even before September. It probably went to seed maybe early August, and then it just died standing. So why is it doing this, right? We hear that plants are supposed to die and deposit their nutrients in the soil so that they can feed the soil and grow for the next year. And as we can clearly see, this material is not going to go saprophytic, and it's not going to feed that soil in time to make any effect on this summer's growth of grass. So why is this grass still standing in spite of it being dead and having completed its journey through the last season? Okay, the answer to this question is that this grass is competing with other organisms in the ground. So it let its seed go into the ground, and that seed now has to pop up the next year. So what it's done is, by staying standing, it actually inhibited the growth of other late season grasses and plants. So some other plants might have had room to grow and had more light hitting them to photosynthesize late in that season through August, September, if these plants hadn't died. But of course, that would mean less space for these plants' offspring. So these plants remain standing in order to inhibit the growth of those late season plants, which would otherwise compete for the land use with the seeds which are now in the ground, right? So that's Phthorapathy. It's competition through the death of a part or whole of that organism. And I have a second example for you guys. If we look over here, we have a tree, and as you probably noticed, this is a deciduous tree. Deciduous trees drop their leaves in the fall. So people tend to think about this the same way. They think those leaves are going to be deposited in the soil, broken down by soil microbes, and then turned into nutrients for the next year's growth. And that may be partially true, but if you look at the leaves which are deposited under deciduous trees most of the time throughout that next growing season, they're not fully decayed. Maybe if you go to certain places where it's real wet and there's real ideal growing conditions for fungi, maybe some of those nutrients will make their way to the tree for the next season, but they're really not helping the next season's growth for that tree. So why, or I should say, what is the competitive advantage to this organism of dropping its leaves like that? And the answer I kind of realized when I was looking at this big leaf maple tree back in Washington. The big leaf maple tree has these big dinner plate size leaves, and those leaves are heavy and they cover a lot of space. And when they fall, you can imagine that any organism without a woody stem underneath those leaves will be both crushed and prevented from photosynthesizing, right? If you had some little baby grasses, some little mosses, some tiny shrubs which hadn't gone woody yet, they would be inhibited from growth and ultimately killed by the weight and the obstruction of light caused by those leaves, okay? And you might be thinking, why would a tree want to do something like that? That tree is not experiencing competition from those tiny little grasses, right? But what is experiencing competition from those tiny little plants which are being killed are the seeds of that tree. So the reason that trees want to have these highly phthorapathic leaf drops is they're trying to kill everything which poses a threat to the continuation of their own lineage. So that's my second example, and I got one more for you. I'm gonna start walking here. So this is actually the first. It's snowy out here, you can't see anything. So this is actually the first example that I really ever thought of with this concept. And this is not a plant at all. I'm talking about salmon. So salmon are a highly phthorapathic species. In fact, they actually almost require phthorapathy for their life cycle to work. I had to put on some gloves. My little fingies were not having it. Okay. Yeah, I mean, it's a lot warmer today. It's like probably 15 degrees right now. So I got that going for me, which is nice. So let's talk about salmon some more. Salmon have a life cycle where they live in the ocean throughout their adult life and then return to the river they were born in order to spawn. And after they spawn, there are some types of salmon which don't do this, like steelhead, but some people consider steelhead a trout. But the classical salmon, the Pacific salmon, they die right after they spawn. And people have similar ideas with this salmon behavior. They say, oh, you're providing nutrients to that stream, you're feeding, the life, the trees, the bears. And the bear part is true, but they're a lot better as a food source for bears when they're alive. So what is the real purpose of these salmon dying off? Because you have to think, if they returned to the ocean for another year and then came back, they would have a much better chance, if they did that year after year, of actually continuing their lineage, if that was the only factor at play. So the reason I realized that salmon die and decay after they spawn is that the process of their own decay depletes the oxygen out of that stream for a short period of time. So perhaps even miles worth of stream with that huge amount of biomass decaying will cause hypoxia in that stream, right? Those bacteria will break down the flesh of those fish and grow to huge amounts of bacteria in that stream, and they will reduce all of that oxygen, essentially creating a dead zone like I've talked about in some of my other videos. So in the process of doing so, they create an environment where downstream for potentially miles, no other fish can grow, right? So essentially they're removing competition for their own offspring, as well as killing potential predators, which might be further downstream and might swim upstream once the adults have gone, right? So essentially, the purpose of the salmon dying right after giving birth is that they're trying to make that stream completely inhospitable to anything else that is not their own eggs, right? And this is why salmon go so far upstream in order to deposit their eggs, is because that way they can ensure that they've reached a point where they're past almost all of the large life in that stream, and then they can die, decay, and kill everything downstream, right? If you look, this is one thing I noticed about the Pacific Northwest. You think of it as having all this life, right? You think of the marine and riverine environments as having so much life, so many fish, but the rivers are barren. The rivers have no life in them. And it's because this process happens year after year after year of fish being killed completely, right? There's no trout living in these streams, hardly at all. And it's because these salmon are deliberately killing off everything else that's living in that stream. So let's get back to phthorapathy. So this brings us to the human purpose, or a potential human purpose in these systems. If we want to increase the productivity of these systems, we can do so by reducing phthorapathy, right? Allowing for more photosynthetic growth by taking down grass, which remains standing, and by removing leaves, which are acting thorapathically to outcompete and kill other plants. Because if those plants are given a chance to actually grow, they will increase the total photosynthetic productivity of the system, and that's what we want. So there's a win-win way to do this, and I'll tell you what it is. It's livestock. If we take some cattle, some sheep, some goats through here, eat all that dead material, right after it dies, we give the late season grasses a chance to grow, right? If we go under these trees and we take our little goats, our little sheepies, they get food, create high value food products for us in the form of dairy and meat. And they increase the total productivity of the system by allowing more life to grow, right? So it is truly a win-win situation. And this is the purpose of livestock and humans in the Phthorapathic equation. So I really hope you liked this video. I enjoyed making it a lot, even though I'm pretty cold out here. So if you want to see more about this, I'm going to be talking a lot more about agricultural systems and how we can improve them and the place of humans in these agricultural and biological systems. So please subscribe, check out my other channel, Fontinalis Health, if you're interested in some of the health aspects of what I have to say about the world, and have a good one. Boop, boop. Is my phone froze? Oh no!